The program has a number of options to customize the settings. We're going to briefly show some of these. So under the Files menu, we have the ability to set configuration parameters. When we open this, we can provide a general description. This is just stored in the configuration files so they can be identified later on. We can define a background image as a JPEG file. You don't need to do this. If nothing is entered, then we just have a blank screen. If you do choose to enter a background image file, then the offsets and image size provide the means to position it relative to your vehicle trajectory data. The trajectory data is positioned according to GPS and is corrected for Mercator grid, so it is defined according to standardized mapping. Path scale and point size are generic. The path scale is related to matching up with the background image. The point size is just the default size of the data points, and these will vary depending on what sort of data you're recording and over what area. We also define the frame rates. We define all times in the program according to frames, and this is where the correlation between the frame rate and actual time is defined. In our default sensor package, we're updating GPS 10 times a second and the inertial parameters 100 times a second. Other input data sources would operate at different frame rates. We have the ability to apply a noise filter to the acceleration data at the moment, so you can turn the filtering on or off. For the case of velocity and the pitch roll angles, the raw data does not contain any significant noise, so we don't need to filter these channels at this time. We also have an ability to set a time offset and whether daylight saving is active. GPS is relative to Greenwich Mean Time, and this way we can set it to local time. We can save these files. We can then load files. They can be saved to any name, but if they use a specified default name, then the program will pick them up if such a file exists when the program loads. We also have an calibration option. So if we load this, this provides a way to add an offset for the accelerometers and the pitch and roll angles. This is so you can remove any misalignment, typically because the sensor box is not perfectly horizontal and possibly not at the center of gravity of the vehicle. There is an ability to load and process the data. So if we select this, we can find a data file, which by default is in a directory called work. If while you're performing your vehicle testing you leave the system running with the vehicle stationary for a short period of time, you'll get static values, and we have several of these from the testing we did. If we open this file, we then find that it's automatically calculated the roll, pitch and heading offsets and the similar values for the accelerometers. This is a useful way to determine what the misalignment of the sensor box is if you don't have information from anywhere else. Again, like the configuration, you can load and save the files, and if a file of a specified name is found when the program starts, it will be read and those offsets automatically applied to the accelerometer data and the angles. We then also have some values in the analysis menu. So if we load a typical data file and we zoom into that area, the coloured dots are drawn at a default size which is set up in the configuration file. Sometimes, depending on the type of data, the dots can be too small or too large, so we provide you with the ability to change the point size. So in this case we can make them, in an extreme case, very large, and all the dots become larger in diameter, and we also can make them very small. So if we zoom in again, you can see they're quite small, and you have 5 levels, and you choose the one most appropriate. We also have an ability to turn off the aerial photo. This is a button on the top right of the screen, and so if you don't have an aerial photo, this will be the display you get. But equally, if you need to closely look at the trajectory path, you can remove the aerial photo temporarily. Also, sometimes the dots, as in this case, are not that clearly identified, so we have a choice of several background colours. So we could go for black. It immediately highlights very clearly the dots. We can also go back to white, where they're much harder to see, and there's also a value for the default, where we go back to where we were previously, and then we can turn the photo back on. We can set colours. We've set what we believe are a good range of colours to display the velocity information, but if you don't like these, you can set the colours. The way this works is to click on the button adjacent to the sample colour. You get the standard Microsoft colour display. We can set a new colour. We can also set any range of colours. And when we say OK and apply, colours in that range have their colours changed. So we see 3 dots have transferred from their default colour to red. Again, if we open the colour menu, you can load and save these values to a disk file. Again, like the other settings, if the file has the appropriate name, then these colours will be used in preference to the internal default colours in the program. And they're most of the relevant options. Or possibly one other useful option is under the tools. There is a distance command. If you select that, you can pick a starting point. You can measure a distance, which will be in metres, to some other point. There is an interactive display next to the cursor, which shows you the distance as you move it. Once you click on that point, that distance is recorded, and you can now start again. So you can calculate distance of each segment and the cumulative distance. This can be quite a useful tool in analysing some aspects of the trajectory.